Alright, so last time we set up some animations. This time we're going to make it so when you press left and right on the arrow keys, it triggers those animations. So right now in the animator, we have player idle and player walk. We are going to switch between player idle and player walk with code. So right here you got parameters. We're going to add a bool called walking, and then right click player idle, click make transition, get this arrow thing pointed at player walk, click on that, select the transition arrow, and under the conditions you want it to be walking is true. So he's in the player idle. When code says that walking is true, then it will go through there to the player walk animation. Now right click the player walk animation, make transition, click back on player idle, select that transition, and make it so that walking is false. So now we will go to the project window, create a folder called scripts, and create a C# script. I'm just calling mine player. Select the player in the hierarchy window, and then drag the C# script onto the player. And then double click the C# script. Zoom this up. So we're going to control his animator. So first we need to go public animator, and we'll just call it player anim. And then this inside the start function, we will have player anim equals get component animator. So now player anim will be this animator. So we got a script right here, and it's finding another component that's on the same game object, and it's the animator that it's finding. And the animator is this area where we can set the walking to true or false. So just to test that, I'm going to save this. So right now when we play, doesn't do anything, the animator is just staying in player idle. But if we were to write player anim dot set bool walking, the name that we gave that bool inside the animator, to true. Now inside here, when we press play, it should transition over to the player walk. So we want to do that when we press arrow keys. There's this thing called input.get axis horizontal, and that is if you're pressing left or right. So if I print that and play the game, in the console window it spits out 0. If I'm pressing left, it gets -1. If I press right, it gets 1. So we are going to, instead of print, we're going to say float walk input equals that. So that equals -1 or 0 or 1 or something in between. And then we will make an if statement. If walk input is greater than 0, then we must be pressing to the right. So print right, else if walk input is less than 0, you must be pressing to the left, and then else if it's none of those things, so it's just 0, then standing still. So if we go to the game, press play, so he's standing still, I press to the right, it says right, if I press left, it says left. So the player must be walking when you press to the right, or when you press to the left. If you're not pressing any direction, we'll put the same code there, except we'll set it to false again, so it turns off when you're not pressing a direction. So now, play this. Press right, he's walking. Let go, he stops walking. Left, same thing. So now let's write some code to make him rotate and face to the right. So transform dot rotation equals quaternion dot Euler. That's in vector 3, so an x, y, and z position that it wants. So x 0, y minus 90, I think, and z 0. Let's just try that. Yeah, so if I press to the right, he's facing to the right. So to rotate him to the left, do the same thing, but just positive 90. And that changes the player's rotation on here. It sets this to minus 90 or 90. So I press right, I press left. So if I'm not pressing any direction, I would want that to be a 0. Save that. Press to the right, not pressing any direction, pressing left. And then to make it a bit smoother, I'm going to use walk input multiplied by minus 90. So that's going to be that number that goes to a minus 1 or a 1 multiplied by 90 degrees. I think I want to do minus 90 for both of those. So now it's kind of a smooth turn. So let's also select the player and add component physics rigid body. I'm going to move my player up off the ground a little bit. So with this rigid body, I'm also going to turn off apply root motion for the animations, because I don't want the animation to push the rigid body around. But he should have physics now. And if I walk around, kind of slides around randomly. So basically he has physics and his colliders inside of him, all these green collider things that are inside of these cubes. Let's show this. This green thing, that's what's hitting the ground. So he's got gravity and physics, and he animates a little bit with the arrow keys. Next time we can make him move around properly. So file, save scene.